Yeah, great to be there. I hope you are enjoying the sessions. And yeah, so a lot of people are talking here about using AI to perform the testing. But my topic is different, right? So my topic is testing the AI applications. Okay. So I'm going to talk about the challenges. And when we see the challenges are going to bring the opportunities, right? So I would like to highlight some of the challenges. Okay. Yeah, I think this slide, Maheshwaran has hacked my slide. Okay. Anyways, so you can see the Amazon's recruitment algorithm, and it got failed, and it was biasing, it was favoring male candidates over the female candidates for the technical roles. So, what is the reason for this? The reason for this was the input data. Right? The input data what we feed it to these algorithms for training data was creating these biases. You can see the another failure with the UCAS admission admission system, so which was flagging lot of applications with the black students for the review. And yeah, again, this is one more failure, right? So again, it was because of the biases, not having enough training data, and yeah, not having a check of a data which we had given as an input to the models, and that created this mess. You would be wondering, even Google had flagged these black people as a gorilla, and they had to apologize for this. So let's see one more example, the self-driving car. There have been a failure here. Okay, so the Uber killed the pedestrian. It could not detect the pedestrian correctly, and it could not take the actions. Now, in this case of a failure, who should be the responsible? Is it the OEM? Is it the driver who was driving? Or if it is an AI, how are we going to punish the AI? Okay. Even Apple had a credit card limit controversy, so it was giving less credit card limits to the women. Okay, so yeah. So when AI takes its own rules, the reward package. Now this is where when you cannot set the correct goals for the AI. It will achieve your one of the goal, but not the right way. Okay, maybe if you ask, you have a robot to clean your house. What if he is pushing all the dust behind the carpet? Its sensors are detecting that home is clean. Okay, but it's achieving the goal to clean the home, but not in the right way. So the reward hacking will happen when you go with the reinforcement learners. Okay, so here you can see the few more examples of the reward hacking. So if your goals are not clear, like for YouTube recommendations, the goal is to increase the engagement. So it's just gonna push the content, the extreme content, okay, which gives us the engagements, but no value. So does we want this one? Do we want it to achieve the goals in this way? Probably no. You can see that here is one example of a side effect. You gave a command to a logo that I am hungry, and make me a dinner. And Robo finds nothing in the fridge. He finds a kitty at her home. Okay. So, this is a summary of what is issues, the failures, what we have seen here. Okay. So, the Amazon's recruitment algorithm was because of a biased training data, lack of fairness in testing. Okay. That UCAS administration admission system, right? This also misinterpreted the diversity in the data. So it created ethical problems. Right? It created ethical problems. Google Photos, again, same thing. Not enough training data was provided, not enough training was done, testing was done, and yeah, so it represented the black people as a movie. And they have to apologize for this. They have to take this product down. They have to take this product back. Self-driving cars. We are talking about autonomous cars. But can something be fully autonomous? Right? So we have to define the limits for the AI systems. We have to define the limits for the AI system, when they should give the control back. Right? When they should ask the human to take control. If you see, these European countries are not giving approvals for this autonomous driving cars because of these reasons. Okay? So, again, who would be accountable for these failures? It's not clear. Okay? Even this Apple car, right? So, again, bias and reward hacking is where you misalign the goals. You set only one goal, the system will learn how it should be achieved, right? So it will learn the tricks, it will, with the help of this, it will achieve this, but yeah, it's not fair to achieve those goals with the tricks and tips. Okay, this is what you know, right? And if our functional and non-functional aspects for the traditional systems. Which one of these will help you to find this kind of failures? Whatever failures we have discussed, any of this kind of a type of testing or the quality characteristics will help us to find these defects? No, right? So there is opportunity, right? Do you see opportunity here? So doing only these aspects is not enough when you are testing AI-based systems. So what are the challenges? Right? So here you have to, when you are testing an AI-based application, you need a different mindset. Right? To have a testability of the requirements, we should be able to predict the expected results. But the AI applications are not predictable. They are probabilistic. Shall we put another AI to test these AI applications? Okay. I don't want to answer yes or no, but I'm just giving you the questions, okay, to just think on it, okay? So, we'll be having a lot of new challenges, okay? So, like expected results are not clear. Many times, even the test oracles, the test basis, is also not fixed for the AI systems, okay? And here bugs will replaced by biases, hallucinations, okay? And yeah, so which will create very bad consequences. So we need testings, right? We need new types of testing. So we should test for autonomy. When the system will leave the control to the humans. Evaluation. AI systems are designed to evolve, run on their own. So it's not that you do a testing and deploy the application in the market and leave it. Continuously monitor. In case of reinforcement learning, the AI applications are capable to learn on its own. So maybe initially they were fine, but later they learn something from the users' inputs, and now they are not doing the correct operations. Biases, ethics, side effects, this is coming from the word hacking. Transparency. These are very important concerns with AI applications. Okay, transparency in interpretability, explainability. Many times we will be wondering why the system or why the ChatGPT has given me this response. Right? So questioning that would be very tough. Verifying that would be very tough. Okay? Safety. So all the concerns, all these are new quality characteristics, all these are the new type of testing what we should focus on, what we should bring on. You might not be saying right now that because you might not be testing AI applications right now, but it's gonna come. Right? Or maybe some of you are already doing it. Okay, so you will see at least some of the components which are AI components in with applications. Okay, if it is not there, it's going to come, and you should be also ready to do the testing for this kind of components as well as the applications. I would like to just review the workflow. I don't know. You can see this. Is it clear? Okay. So if you see here. So how we build these models? Okay, so we define the objectives. Once we define the objectives, we should be gathering the data, right? Parallelly, we should select the model. So we should gather the training data, we should select the models. We should test for the data, we should also test for the models. Now you see here, there are two new test levels which are coming in. What are these two test levels? Testing the data. Right? Another is testing the model, including the training data and then the algorithm for the reward user. So this would be also another opportunity what we will see. Okay, we should be ready for this. These are some new test levels what you see when you are testing the test applications. So we should test the input data because this is what is gonna the machines are gonna learn from the input data, and if the input data itself is not correct, not complete, it has biases, it's gonna exploit the same, and that's where you will see that you are not getting fairly enough answers. Okay. So more importantly, we should review the data. There are statistical techniques which we can apply, exploratory data analysis. So many times we have to also plot this data, visualize this data so that you find the problems with it. And yeah, the reviews comes into more importance here. And we should question, as Maheshwaran has mentioned. Now the reviews are very critical because with AI coming in, we may lose the ability to question. We may directly believe that what the AI is giving us always right. But we should be thorough in questioning those outputs. Okay. Even the algorithms need to be tested, the models need to be tested. And when we are testing these models, does our traditional coverage will be enough? The code coverage, statement coverage, branch coverage, requirement coverage? No, right? Obviously, those matrices are gonna not help you here. So we should be also measuring the confusion matrix. Okay, so we should be measuring the accuracy. Right? Accuracy, precision, and also there is a sensitivity which is called as a recall. So there would be a new matrices, because the statement coverage, branch coverage, the requirement coverage is not going to help you here. It's not enough here. Okay. Now here is a one example for a spam detection. Okay, so you can see if there are, you can see the actual and there are predictions. Okay, so yeah, many of the times here the spam detector could able to identify which are all emails which are spam, maybe once it is spelled, but that's really accurate or that is the pretty precise system. So in case of a spam detection, we should focus on the procedure. But let's say if you are to test the polio detection systems, now here the focus would be not on the precision but on the recalls. Right? We should not fail to identify the positive here.
Yeah.
If someone is negative but you are calling it positive, it's fine here because he will go for further investigation. That's all there. But if you are failing to identify here, that's a problem. So some applications we are going to require to focus on the precision. Other applications you may be required to focus on recall. There could also be some of the examples where you need to focus on both of these. Again, these are the functional aspects. So we should also test for the non-functional aspects. Now, training a huge data is going to take a huge resources. And we want the systems, the application should be learning when they are in operation, right? So it's a continuous demand of the resources. Adapting to the new data, right? So something, if we are training the applications on the old data which is not relevant, maybe we should go back and retrain the model with the latest data. So it's gonna be always required. Okay. So we should validate the choice of framework, the algorithm, even algorithms will have a lot of settings, tuning, okay, so that you get a better results of it. The coverage wise, we should focus on the neuron coverage, not just on the statement and the branch coverage. We should test even for a concept drift. Now, what is a concept drift? Let's say, testing for some learning system. So here, it's more of So there could be when it is in use, there could be a performance degradation. Maybe initially the system was working fine, but later as it gets more data, the performance is going down. So it's not with the AI-based application. It's not that you test it once and you do it. It's like a kid, right? So you can't teach the kid. Okay, so you have to also monitor him how it's performing, right? So you can't just put him in the school and leave it, right? You have to also monitor what he's learning, right? With whom he's getting in, right? So we have to even monitor during the operations. Okay. Metamorphic testing. This is another thing what we should be doing when we don't have a concrete expected results. When we don't have a concrete test oracles. The metamorphic testing is where you find out the relationships and you check whether the outputs are being changed with these relationships. Okay, so maybe that Apple's credit card limit system that could have been tested for the same input data. What is the credit it is allocated? One for the male, one for the female. Only by changing the gender. If you were take the single results, it's unbiased. The system has not learned the biases, the gender biases. Okay, so here you can see an example. Here there is no example. The example will come on next. But here you are using one test case, but you are changing slightly the input, and you are expecting the similar change with output. Okay, so maybe this example will be clear for you. Okay, so let's say there is an application which is determining the age, here which is predicting the age. Now you have a test case, you give an inputs, and it's doing some prediction. Now, this input test data you're changing. Now you are increasing maybe this. You are increasing the smoking, right? So the date details with the 10 more cigarettes smoked per day. Now it shouldn't be more than what we got earlier. Okay, so the age prediction shouldn't be more than what we have received the first time. Okay, so this is called as a metamorphic testing, where we test for the relationship between the inputs and outputs. So we identify how the relationship should be, okay, and then we test for this. This is another example where maybe you are giving A plus B, seeing what is output, and next time you are giving B plus A, maybe you should get the same thing. Okay, so just doing testing once may not be enough. Okay, you have to change the inputs and then see how the output is reflecting to these different inputs, and whether it is reflecting in the right way or not, what you expect or not. Now, talking about where is AI right now, you see, there are three types of AI systems: narrow, general, and the super. Now it is a narrow. So it's a kit right now. AI applications are kit. Okay, they are not better than the human right now. But yeah, they can be equaling us. That is what is a general AI, which doesn't exist right now. And the super AI is again the concept. Okay, so with power of the data and the machine learning, yeah. So AI can be superior, but yeah, it's gonna take huge time, right? You can see AI, I think 1950s we started AI, but now it's picking up. Okay, so it's gonna take few more years. I don't know super AI to see the super AI will be there or not. Okay. Okay, but yeah, so this is what you see. Right now we are nowhere with the AI, but it's always good to learn AI. I would say you like AI, you don't like AI, but you learn it. Okay, so that's very important. Okay, and always have that curiosity to question. Okay, and anyone of you have seen the movie Human in the Loop? How many of you have seen the Human in the Loop? None of you? Really? How many of you have a Netflix subscription? Okay, can you write down the movie name? Human in Loop. Okay, it's there on the Netflix. You can watch it. It's just 1 hour, 10 minutes, or 15 minutes. You will understand the challenges, the problems, the human biases, what can influence the AI. Okay? Okay, this movie was recently released. It was released on very few theaters. Okay, big screen, but now it's available on the Netflix. You can watch this. You will identify how important it is to train the AI models like a kid. Okay, so if you see even this picture, the AI systems are right now are as a kid. Okay, let me just show you some tools. Okay, so just to understand how these AI systems are built. Okay, so I'm opening one tool which is named as a wake up. Okay, my slides are over. Okay, slides are over. Okay, it's opening one. Let me just wait until it opens and then we will it. Anyone of you know this wake up? Anyone of you can use this wake up tool? Okay, let's take it on. Okay, Meanwhile, any questions? Like, yeah.
So, yeah, you mentioned that we cannot do the AI testing once it is tested, right? We have to perform iterations on the AI models, right?
Yes.
So, how to decide that which is the right time to stop? How many iterations? After how many iterations we should stop? How to decide that?
Yeah. So, see, there are matrices, there are like measurements. What you can do is with respect to the neural networks. Okay, so you can measure the neural coverage. That is one way. Another thing is we have to measure the accuracy. Okay, so we have to have enough data which we can use as a test data. More importantly, we should keep our test data, the training data and the test data separate. It can't be the same. If it is the same, you're going to get 100% accuracy. Okay, so we should have enough data for the testing, and it shouldn't be the same data as your training data. If it is the same data, you will see always 100% accuracy, and which may not be more. Okay. Okay. Let me just show you this.
Sagar, one question additionally.
Yeah.
Any?
Yeah.
Yeah. By knowing the maturity level of AI, is there any centralized or regulated body which makes a kind of standardized procedure or no process
Yes.
how to track what do's and don'ts?
Yeah, there were regulated bodies because there are a lot of standards.
Like
there are
ISTQ.
AI which are coming in. Okay, so I think in Europe there are a lot of AI acts which are already in place. Okay, even this GDPR guidelines they also have added these AI regulations in it.
Is it country based or
It's a
region based, not
it's a
centralized
I
one?
don't have anything which is worldwide.
Unique one.
Yeah, unique one we don't have yet. Okay, so it's a contribution for us.
Start.
Okay, let me complete this and then take the exam first. Okay, so that I just wanted to show you the flow so that you understand. And this tool is a free tool. Okay, this tool is developed in New Zealand, and Vika is the name of a bird which is generally found in New Zealand. Okay, and this is a free tool which you can use. Now what I did is I just opened this and clicked on the explore button here. Okay. Now there are three steps. One is that I'm gonna I'm just gonna give an input file, any data file. Okay, so this is predominantly it has like an Excel CSV file which has a huge data. Okay. Now let's say I take a data of a class. Now here I'm loading the data. Now you see there are a lot of inputs, and based on these inputs, it is determining what type of class it is. Okay, so this is our training data which I am giving as an input here. Okay, now I can go on the next tab, which is a classifier. Now here I have to choose the algorithm. What algorithm I should apply? Okay, so I'm just gonna go here. There are a lot of algorithms. There are machine learning algorithms. There are fuzzy algorithms. Okay, you can explore this. But my favorite is a random forest, which I'm gonna choose. Now, if you choose, here you can tweak your algorithm. Lot of parameters to algorithm. So generally, when you are building machine AI-related applications, you are gonna reuse these algorithms. Unless and until you are not doing the research, you will not develop the algorithms. Lot of algorithms are already developed, which you are going to reuse to train your data. And you will have a lot of parameters to configure these algorithms. Okay, I'll not go into it, but I'll choose here maybe, cross validation and 10 floors. Or maybe I can go with a percentage split and I'll give 80-20 split. Now what it means is, what is the data I'm giving as an input, out of which 80% data, this tool will use to validate this algorithm. 80% data it will use to train this algorithm, and the remaining 20% to do a testing. So it's not going to use the same data, but it will split the data randomly. 80% instances it will use to train the model, and the remaining 20% to test. Okay, I think this is good. I'm going to start here, and you see this algorithm has learned the data what I gave as input. Okay, and some part of this training input data it has kept for the testing date. Okay, the 20%, and now you see there are some matrices. Okay, one matrix is how fast was this, how quick the algorithm has evaluated. So it is very fast, 0.01 seconds, right? Second thing you can see, the correctness, the accuracy, 67%. Not that great, right? But you see there are, I think, 8 or 9 outputs, so 67% with these many outputs should be good, right? There is a lot of classification, A to G, right? So with that, it's not just a binary yes or no. Maybe if it is yes or no, then the 65% may be not that accurate. 67% may be not that accurate. Yes, it's fairly accurate, I would say, but still not that great. Okay. And then here you see the confusion matrix. So how many times it has been correctly classified? How many times this particular class has been wrongly classified? Okay, so this tool maybe you can explore. So I just wanted to explain you the process how we develop the AI-based applications. So we give a training data, we choose the models, we configure the models, the algorithms. Okay, and once we have this training data and the algorithms, we get the models. Okay, and here the important is to test the input training data as well as the algorithms. So probably you will not have a component testing for these models, but we should have this kind of a testing, the input training data testing as well as the algorithm testing. Okay, that's it. Okay, so you can note down the tool's name, Veka. I want you to explore. You can also do a search on YouTube and you will find some of the good videos explaining this. Okay, so the machine learning. Yeah. Yes.
So, what characteristic are we using to identify what is correctly identified and what is not? Because
See, right now it's using the input data. So if you see the input data, we are giving this as an input. So this data we should be having it. So some part of the data right now it is using to train the model, and some part of the data it is using for the testing the model.
correct, but
Okay. Good.
what is its
Okay.
parameter?
I'll show you here. Okay. So this random forest, right? So now if I click here, okay, I should apply some different model so that I can show you. Okay, let me choose the another model, something from here. Do the assumption and let me run this. Now I'm going with a different algorithm now. Okay, and let me start running the same thing. Now you see a different accuracy. Okay, you will see a different accuracy. Was 55% accuracy. Okay, now I can change the algorithm. Okay. Let's say the visualize classification. What is it? Yeah, classification here. Okay, still I'm using here. Okay. Let me choose another one. Let's J28. Yeah. So here I'm going to, So if you see this algorithm, it's analyzing these parameters. Okay, so this is one of the classification tools which I can show you. Otherwise, it's very difficult to explain, right? What AI is doing, what algorithm is doing. Okay, so here you can see it is analyzing the data, it is classifying it, it's creating a tree, and this it is using to classify the
Correct.
testing method. Okay. Okay, so it's based on the algorithm, how it's going to work. Okay, different algorithm will have a different logic how it can work there. Okay. Okay, any other questions? And
Yeah, one slide you mentioned how to train ethically.
can you raise your hands? Okay.
You mentioned ethical validation of the AI system, right?
Hmm.
Ideally, AI system works on the data and the historical events what we input to the model. But how do we train ethically? I don't know, like, that was
Okay. See, one part is when we are giving the input data, now you see a lot of visualization here. Okay? So, how the AI is going to learn the biases? Come over the input. So, here, important is to test our input, the input data. Okay? So, let's say there is a Apple credit card, the credit limit AI application. Let's not give a gender as an input.
But technically, region to region it changes, right? Like,
Right, obviously. It's-
because in India, ethical things are different. In other
So
countries,
there are a
other
lot of
countries are
questions,
different.
like lot of questions. Okay,
Yeah.
so there is no one answer. Like let's say you are having a car, okay, and as of sudden someone comes in front of you, okay, and let's say it's an autonomous car. So whom the car should save? The inside, who is inside the car, or the who is outside? Okay, so this could be a debatable question, right? So yeah, there are no concrete guidelines as such here.
Yeah, I've seen people like putting a left signal and taking a right also. So how do I test the autonomous car system here? Because my car will leave the indicator taking as a left, but I've seen like by mistake they put a left indicator, but they'll take a right.
Okay, was it the main private or
That time I'm coming from bias one. No comments on that.
so if it is female driver, we should consider opposite. Okay? If it is left indicator, it's gonna be.
It will be bias, right?
Okay. Okay, that was one question. That was up.
Yeah. There was a slide with respect to self-driving cars and the real world simulation. So under this similar scenario, I wanted to know how about these scenarios taken into consideration over there.
Sorry, I missed. Can you come again?
So there was a slide previously, self-driving car was the testing scenario. And at the end of the last column, there was like real world simulation. So when such scenarios come into consideration, so multiple scenarios, multiple test cases all come into consideration.
Correct.
So who to say? So who is inside the car or outside?
Yeah,
So
that's under the investigation. So there is no right answer actually.
Exactly, yeah.
Okay, there is no right answer, sir. And that's where the AI should give you the control to the human. Okay, so this is about the autonomy.
Yeah.
So the system should understand when they should leave the control and give it back to the human to take the actions. Okay. So this is where we should test for autonomy. Okay.
Yeah, I also have a question.
Yeah.
So we also discussed multiple things when we are testing AI, autonomy, evaluation, biasness, ethics, all those things. So suppose any person is testing the AI model for the first time. So what approach should we follow? Where do we start with? Because there are a lot of things, right?
Okay. So again, so you're asking how much is enough, right?
Yes, how much is there and where to start with for the beginners who have received the testing the AI or LLM model for the first time.
That's what. So here, when we are testing AI-based application, you can't fit it into when we are testing like traditional applications. First, we are not going to have a conflict requirements like how you will have in a traditional applications. You can't say that line by line, word by word, what is detected should the AI should. It's not going to happen. Okay, so this is one thing. Secondly, there should be boundaries defined. What is acceptable, what is not acceptable. So always it's not a binary in case of AI system. It's not a true or false. It's what is how much accurate and how much fair. So we have to also look into the matrices what we collect. So fairness is another matrix. Okay, and again it could also depend what is fair and what is unfair. It also differs with the person to person, right? So we should have a clear guideline what is the fair output, what is unfair output. What are the limits to accept, what are the limits to reject. Okay, so it's not always binary that you fit into one step. So
I think we are also using confidence scores in the
Confidence,
applications,
right.
right? Where we so how to decide how to rely on that confidence
see,
score.
it's based on the context. As I showed you, say you need a different baselines with the matrices for the different applications. Okay, not one baseline will apply for all. Like maybe as I mentioned, so if you're testing medical applications, it's okay to flag someone who is not a diabetic as a diabetic. But it's not okay to flag someone who is a diabetic and as a not a diabetic. Let's say there is a traffic violation system. There it's okay to not to find someone who has not wear a seatbelt. But it's not okay to find someone who has wear a seatbelt. Right? So it changes based on what application you are testing. Okay, so we should define what matrices and what values we are accepting. Okay. Thanks, then. Okay, so if you have any further questions, you can comment on the line. Thank you.